Hi guys, welcome to our second computer lab session, and in this week we're going to use R to run simple regression and do some hypothesis testing using the capital asset pricing model as an exercise. To brush up on the theory side is basically regressing the excessive return of the risky security on the excessive return of the market portfolio. So the dataset can be downloaded from Canvas, and it basically consists the price of IBM, the SP 500 index level, and also the return of the 3 months T-bill. So yeah, I assume that you already download the data from the from Canvas, and in this video we're going to import this data into R and then do some data transformations so that we will be ready to run the regression in the next video. So let's set working directory and then read the file into R and then use the stir functions. And as in the last computer lab exercise, we found that like when we load data into R, the date column is going to be stored as character because of we set the string as factor equals to false, and then and it agrees that like and by the column names you might already guess that like the IBM by the prefix of the column names, you might already guess that IBM and SP 500 is given as the price level, and the risk-free asset is given as the return level. So and CAPM use excessive return, right? So we are going to calculate the return from for IBM and SP 500 from the price of itself, and then subtract it from the return of risk-free asset to get the excessive return. Yeah, so let's begin the data manipulation, and we are going to use the transform functions to coerce the date class, the class of date column into the right type. So the first argument we provide is the data frame, and the second argument is the operation itself. So it's basically what we're going to do is to assign the output of the expression on the right hand side of the equal sign into the column name provided on the left hand side of the equal sign. In this case, date column already exists in data frame, so it's going to replace the existing value. In case you want to create a new column, you can give column names that are not exist in the current data frame. But yeah, in this case, we'll just simply overlap it, and then when you run the stir function again, you can see that like now we have the right data type, the date class for the date columns. And then the second thing is like we would like to create a character factor for the column names. We could simply use the combine function C to create a character factor like this. But I would like to introduce the paste functions to you as well, like as it would be a very convenient way to concatenate two factors, and for some cases you want to concatenate a prefix or service. It's going to be very fast to use paste functions when the character string is getting longer and longer. So yeah, is simply use the combine functions and paste function, and then you create the character factors, which will be used as the column names in very soon. And then we're going to create the matrix with 3 columns, as like the length of return name is 2 plus 1 is 3, and n row is like 1 row less compared to the price level, because there are no elective price for first observation in this data set, so we can't get the return for the first observations, right? And then after we create this matrix, we use the s.data.frame to convert it to data frame, because the first column is going to be because we are going to include a date column, right, which is with the different type of the which is not a numeric type. And we know that for matrix, each column has to be the same type, so we need to use data frame instead. And then yeah, so we just create empty data frames for return data frame. And oh, sorry. And then we're going to for the first column, we're going to assign the we'll start by modify the first column of the return data frame, taking the date column in the data example 2, except for the first row. Like everything after comma is column, and the everything before comma is row. And then if a positive integer is provided, it means like we're going to select the elements at that positions, and negative is that we're going to drop the elements at that index. So it simply means that like the first column of data example 2 excluding the first element, the first row. So we're going to assign this value into the first column of the return data frame, as as here we see that after comma is column, right? And because nothing is provided, then it is all rows. And then if you we just fill up the column, the first column. And we would like to there's a function called call names, which can be used to retrieve or set column names. So if we simply type call names, and then we can see that it's because we simply create the matrix without providing the column name, so by default it's something V1, V2, something like that. But now we're going to to set the column names using the character factors that we created not long ago, and it's going to combine string dates with the return names that we put. So if we check it again, now we have the column names for the return data frames. But if we check it again, it is the second column and the third column is still empty, right? So as in the first computer lab exercise, we're going to write a functions to calculate return, which is going to differencing the from the left value, and then develop a left value times 100 to calculate the return in percentage. And then we would like to apply the functions written to the price of the second column and the third column in the data underscore example 2, right? It's we would like to apply the function written which is the cal return to the second column and the third column of the data underscore 2, and then we're going to assign the return value to the data frame to the second and third column of the return data frame, right? So -1 means excluding the first column, and in this data frame there are 3 columns, right? So it is equivalent to say C23, and here as well, like it is same as C2 or 3. So -C14 is just excluding the first and the fourth column, which is the dates column and the risk-free return columns. So we apply it, and then we have a look again. We can see that like the return of IBM and SP500 is calculated, and again, like the last step, like CAPM regress the excessive return of the market of the risky security against the excessive return on the market portfolio. So we could so we still need to subtract it from the risk-free asset return, right? Sorry. So first of all, we'll add the risk-free rate to return data frame as well. In this case, like we are going to it's equivalent to say oh man, sorry, I forgot. So we could create a column like this using the character name, but we can also use another subsetting operators beside the square bracket. We can use $sign. So it's basically assign the first column, not the first column, the risk-free return column of the data underscore example 2 into excluding the first observation into the return data frame, and then if you have a look, and you will see that like we have one more columns in the data frame, and then we generate the excess return by subtracting it. And again, now we have the data frame ready for us to run the regression in the next video.